Hello dear students, welcome back to my lesson, and I'm very happy to see you again. New lesson, chapter 1, section 1. As you know, in a previous lesson we stopped it here, and today's lesson we're going to solve the questions of the section review in section 1, chapter 2. Just for reminding you, in a previous lesson we studied the object, about the point mass of the object and the extended object, and also we have studied the torque and the lever arm, and we solved many questions that related with the torque. You know that the torque is equal to force times the distance times sine theta, and the torque depends on the amount of force that measured in Newton, and the lever arm, and the angle between force and distance. Okay. The question 1 in section review, section 1, chapter 2. In which of the following situations should the object be treated as a point mass, and in which should the object be treated as an extended object? As you know, just for reminding you, when the object has only translational motion, the object considered to be a point mass. Okay, but when the object has rotational motion, or has both rotation and translational motion, such as rolling object through a flat surface or from the incline, in that case the object is going to be an extended object. A very good question, and it has been brought in Wizari exam many times. Be careful. Okay, a ball dropped from the roof of a house. Because the ball is dropped, it means that it doesn't rotate. Okay, so it means that this ball has only translational motion from one position to another position. Okay, so that is why the object considered to be or treated to be what? Point mass. But in B, branch B, a ball rolling. What do you mean by ball rolling toward the goal? Assume that this is goal, okay? This is goal. When the ball is rolling, so what is the type of motion of this ball? Both rotational motion, and translational motion. Because the ball has both types of motion, so that is why the ball, in that case, the ball treated as an extended object. Why? Because it is rolling. It has both rotation and translation. Branch C, a pinwheel in the wind. You know that the pinwheel has a fixed point, okay? And it is rotating around itself about a specific axis, okay? So, because the pinwheel has only rotational motion, so that is why the pinwheel treated as an extended object. Look at D and pay attention, please. Branch D, earth traveling. Because the question says traveling, it means that it describes the movement of earth or orbiting earth around the sun. You know that earth has both type, rotation and translation. Okay, because the question says traveling around the sun, it means that we have to ignore the rotation. So it means that the object has a point mass only, or the earth has point mass. But if the question says earth rotating around itself, in this case, the object of the earth becomes what? Extended object. But in the case of traveling, you have to say earth considered or treated as a point mass. When does earth treated as an extended object? When the question says earth rotating around itself. Why? Because it describes the rotational motion. Okay? So this is very important. Be careful, please. If you see in the Wizari exam, earth rotating around itself, you have to choose the extended object, not point mass. Question 2, what is the rotational analog of force? Rotational analog of force is torque. Now I'm going to write some linear quantity. Okay, and rotational quantity. Okay, the first one, force, is a linear quantity. It is rotational analog is what? Torque. What is the rotational analog of force? You have to say torque. So it has been brought in Wizari exam many times. Be careful. Okay, and Omega angular speed, sorry, velocity or tangential speed or linear speed, its rotational analog is what? Omega. Acceleration, its rotational analog is what? Alpha. Okay? Displacement, its rotational analog is what? Angular displacement. Mass, its rotational analog is what? Moment of inertia. We will study in section 2 and 3 in this chapter. Okay? So these are some examples of the rotational analog of linear quantity. Okay? In this question, what is the rotational analog of force? Force is a linear quantity. Its rotational analog is what? Torque. On what quantities does it depend on? What does torque depend on? Torque, measured in Newton meter, and it depends on what? Force, according to this equation, F d sine theta. Force, lever arm, which is equal to d sine theta, and angle between what? Force and distance from the axis of rotation. Okay? Look at question 3. Very good question, guys. Pay close attention, please. Listen carefully. How can you solve question 3 in section review, section 1 in chapter 2? Question 3 says, calculate the torque of each force. The figure is given in the question. Okay? How many forces do we have? As you can see here, how many forces do we have? We have 3 forces. Okay, now I'm going to rename. This is F1. Assume that this is F1, this is F2, and this is F3. How many forces do we have? We have 3 forces. How many torques do we have? We have 3 torques also. Why? Because each force is responsible for the torque. Okay? But sometimes the torque becomes 0, and sometimes torque becomes positive value, and sometimes torque it becomes negative value. It depends on the situation. Okay? Calculate the torque of each force acting on the bar in this figure. This is bar. Assume the axis is perpendicular to the page on the passes through point O. Where is point O? This is point O. So it means that this is what? This is axis of rotation. What is this? This point is what? Is axis of rotation. In what direction will the object rotate? We have to find what? We have to find net torque. Net torque is equal to what? Torque number 1, torque 2, torque 3. Why? Because we have 3 forces. Okay? This is torque number 1. Okay? Okay. Torque number 1 is equal to what? Is equal to 0. Why? Because do we have force? Yes. Do we have angle with distance? Yes, of course. So should I convert this angle? No. Why? Because it is with the distance or with the arm. Okay. So do we have distance? No. D1 is equal to what? D1 is equal to 0. For any force, this force acting on the axis of rotation. So distance is equal to 0. When does distance equal to 0? When the force applied on the axis of rotation. Okay. As I told you, when the force applied on the axis of rotation, in that case, no torque produces. Torque is equal to 0. Even if we have force and angle. But we don't have D, so that is why torque number 1 is equal to what? Is equal to 0. Torque number 2. Look. Torque number 2. How can we determine torque number 2? Torque number 1 is equal to 0 when force is equal to what? 30 Newton. Torque number 2 is equal to what? F2 D2 sine theta 2. Do we have F2? Yes. Was given 25 Newton. F2 25 Newton. F2 provides the clockwise direction rotation or counterclockwise rotation. This is the bar, okay? When the force applied like that, upward force, the upward force provides what? Counterclockwise direction. So that is why it's going to be a positive torque. F2 produces what? Positive torque. Why? Because it is rotating counterclockwise. Okay? And do we have D2? D2 was not given in this question directly, but I know the entire length of the beam was given and is equal to 4 meters. What is this 4 meters? This 4 meter is the whole distance of what? Of the bar. Okay? But F2 is located exactly at the middle of the bar. Okay? So that's why we have to divide this 4 meter by 2 so we can get 2 meter. D2 is equal to what? 2 meter. How did you find D2? Because you have to say, teacher, the whole distance of the bar was given, which is equal to 4 meter, and F2 applied at the middle of the beam, okay, as you can see. So that is why we have to divide this 4 meter by 2. We can get D2, which is equal to 2 meter. So the most important thing here is the angle. Guys, be careful. Theta 2 is equal to what? Please don't say 31. This is not 31. Guys, be careful. So when we say torque is equal to Fd sine theta, this angle, it should be between force, this is force, and distance. Is this angle between force and distance? No. This angle is between force and this perpendicular line, this imaginary line. So that is why we have to convert. If this angle is 30, what is this angle? It should be 59. 59. Why? Because in that case, 90 minus 31 is equal to what? 59 degree. Okay? And also you can say this angle, to find this angle, yeah, between this force and here we have 90 degree. Here what's remain? 31. 31 plus 90 is equal to what? 121. Which one can be used? Sine 121 or sine 59 is the same, up to you. Theta is equal to what? 90 minus the given value. Given value 31, which is equal to what? 59 degree. Torque number 2 is equal to F2, replace, was given 25 Newton times D2, 2 meter, times sine what? 59 or 121. Both are correct. Why? Because assume that this is beam and this is force. Okay? If this angle was given 31 degree. Okay? What is this angle? 59. So this is force and D, yes. This is force and this is D. So, and could you write down like that? Find this angle? Yes, of course. Why? Because also this is force and this is D. But in that case, we have 90 degree here, and also we have 31 degree here. 90 plus 31, it's gonna be 121 degree. Both angles are correct to find torque number 2, which is equal to positive what? 43 Newton meter. This is torque number 2. Okay. Torque number 3, as you can see here, look. Torque number 3 is equal to what? F3 D3 sine theta 3. F3 because this force is downward in a tilted angle, so that is why the beam is rotating clockwise direction. Okay? How did you find the direction of the beam according F3 when 10 Newton? You have to say because when the force is downward in a tilted angle, so that is why this rotation is going to be what? Clockwise direction, and it's going to be what? Negative. Negative F3. Do we have F3? Yes. 10 Newton. Do we have D3? Yes. Because this force is applied at the farthest point from the axis of rotation, so that is why D3 is equal to what? 4 times. This angle is between force and D, yes, of course. This angle is between force and distance. And also you can say this force between, this angle between force and the extension of the distance. Okay? So that is why you don't require to convert this 23 because it's already with the angle between force and the distance. Torque number 3 is equal to negative what? Negative 16 Newton meter. Okay, now we can finding the net torque acting on this beam. How can we determine net torque? As I mentioned before, to find net torque, you have to add up all torques, all the individual torques. How? Torque number 1, 0, because located on the axis of rotation. The force applied on the axis of rotation. Torque number 2, we found it 43. Plus, torque number 3 was negative 16. 43 minus 16. Which one is bigger? The positive 27 Newton meter. What does this negative sign indicate for the net torque? This negative sign indicates that the beam rotates counterclockwise. Okay? If you write down the positive sign, you are not required to write down the counterclockwise. But if you don't write this positive sign, you have to write down what? Counter or anti-clockwise direction. Okay? It was a very good question, guys. Pay attention, please. Question 4. How would the force needed to open a door change if you put the handle in the middle of the door? Very good question, guys. We have a door here, okay? The handle of the door is, at first, is located at the farthest point from the axis of rotation. What is this? This is axis of rotation. In the first case, you have torque 1, D1, and F1. Okay? In the second case, if the handle of the door is changed from the farthest point, if we change the handle of the door from the farthest point to the middle of the door, so it means that D2 change it is equal to half of D1. This is axis of rotation. Which one has more axis of rotation? This handle or this handle? Absolutely, this handle has the farthest distance, has more distance, but this one has less distance. Which one is bigger? D1 or D2? Absolutely, D1 is bigger than. D2 is equal to half of D1. Or you can say D1 is equal to twice of D2. So, in that case, the force is force is inversely proportional to the distance. Why? Because torque is equal to Fd sine theta, okay? Force is equal to what? Is equal to torque over d sine theta. At constant torque, both cases produces the same torque. At constant torque, what is the relation between force and distance? Inversely proportional. Less distance require more force. Logically, which case or which example requires more force? If the handle of the door located at the farthest of the door or located at the middle of the door, so you can test logically in your daily life, absolutely this one requires more force. So that is why the handle of the door of car, of house, always located at the farthest distance from the axis of rotation. Okay, so that is why force distance becomes what? Becomes half. 1 divided by half. F2 is equal to 1 divided by half is equal to 2. Twice F1. It means that in the second case, we require more force, twice force as the first case to open the door and to produce the same torque. If we apply 20 Newton to open this door, but in that case, we have to use what? Twice of 20, it becomes what? 40 Newton to produce the same torque. Okay? Okay. Question 5. Physics is in action. How does the length of the pedal arm on the penny farthing bicycle affect the amount of the torque applied to the front wheel? Absolutely, this is the bicycle. Okay, this is the pedal. More distance, this is axis of rotation. This is force. Okay, more distance produce more torque at constant force. Why? Because torque is directly proportional to the torque. Distance, torque directly proportional to the distance from the axis of rotation. More distance from the axis of rotation at constant force produces what? More torque, and it goes to rotating the bicycle more and more, okay? And how the torque changes? When the length of the pedal changes, the torque increases when the pedal arm increases, okay? To find half of maximum value of torque and 1/3 maximum torque, a quarter maximum torque, just write down, for example, when does torque becomes half of its maximum angle, the torque, in which of the following angles the torque becomes of half of its maximum value? You have to find the sine inverse of half. It becomes what? 30 or 150. Another question, when does torque becomes 1/3 of its maximum value? Torque is equal to 1/3 maximum value. You have to write down what? Theta is equal to sine inverse what? 1/3 is equal to what? In this angle, at constant force and distance, in this angle, the torque becomes 1/3 of its maximum value. When does the torque becomes quarter of its maximum torque? When the angle is 14.47 degrees. Okay, so this is classroom practice. I hope you solve this question by yourself, and if you don't understand and if you don't if you cannot solve this question, feel free to ask me and leave a comment on the YouTube. Okay, I'm gonna explain and I'm gonna solve for you. Okay. So we finished it, section 1. Here we have many wizardry questions. You know that my pamphlet is one package. All wizardry questions are included with the all assessment guidance questions are included in my malzama. Okay. So you can solve all the questions. If you don't understand any question, feel free to ask me. And you can contact me through the WhatsApp and any other way to reach me, okay? Section 2, about the rotation and inertia. In this section, you will be understand about the moment of inertia of the object when object is rotating. If you remember in grade 11, you have learned the Newton's first law. An object at rest remains at rest. An object in motion continues in motion unless acting with any external force. So in that case, if in the absence of any external force, the object at rest remains at rest, or the object in motion continues in motion. Okay, but in the presence of the force such as gravitational force, air resistance, or any other forces, the object cannot maintain in its motion. Okay, so. And also, the inertia is the tendency of an object to preserve its state in motion or at rest. What do you mean by that? As you learned in grade 11, the object with the heavier mass has more inertia. Why? Because, for example, when the object has more mass, it preserves its state at rest. Okay? You cannot, by using the small amount of force to moving this object. Why? Because the object has more mass. Has more mass, it means that has more inertia. So that is why you cannot move this object by using a small force. You require what? Require more force to moving this object. After being applied more force on this object, the object start moving. When the object start moving, it's not easy to stop this heavier mass. Why? Because it has more inertia. So that is why sometimes we can say the Newton's first law is the inertia. Okay? And the center of mass, as you know, the point at which all the masses of the body can be considered to be concentrated when analyzing a translational motion. For regular shape, such as this regular beam, where is the center of mass of this beam? The center of mass is located at the middle of the beam. So sometimes the center of mass is called the balancing point. At which point you can make this beam as balanced? At the middle. Such as you can see, for example, this pen, okay? I balanced this pen on my finger. So where is the center of mass? The balancing point is the center of mass, okay? So that is why for the mostly of the times, we can say the center of mass and the center of the gravity is located at the same position. Okay, so also we can say this is center of gravity. Center of what? Or you can say what? Center of mass. Center of mass, okay? And for the center of mass, in some case, we have to find the center of gravity, and in the mostly of the cases in this book, the center of mass is equal to the center of the gravity, okay? Center of mass of all object has only translational motion. As you can see in this picture, when this guy thrown this object, this bottle, okay? In that case, where is the center of mass? The center of mass is located here, okay? The center of mass has only translational motion, okay? For example, if you throw this bat, this is center of mass, okay? In the case when you're throwing the bat is rotating around the center of mass, okay? Okay, look, the center of mass of all objects, they are moving what? In a translational motion only, in a parabolic motion. Center of mass tracing the path of a parabola, okay? What about the ends? The ends of the object is rotating, okay? The end of the beam is rotating, but the center of mass has only translational. So, it means that when we throw a bat into the air, describes the path or the types of the motion of the center of mass. The center of mass has only translational motion. Center of mass has only what? Translational motion. If you throw a bat into the air, even in the case rotating the bat, the center of mass has only translational motion, but it's in a parabola tracing because of the gravity, okay, in the absence of the air resistance, okay, but the end has rotational motion. The center of mass object has only what? Translational motion. It means that point mass. Imagine you throw a stick up into the air and stick is not attached to anything. There is a special point around which the stick rotates. If the gravity is the only force acting on the stick, this point is called what? Center of mass. The center of mass has translational motion in parabolic motion. Thus, the stick has two types of motion, translation and rotation. The center of mass has translational motion, but the end has what? Rotational motion. So in that case, we can combine both of the motion together, combining rotation and translational motion together. The center of mass is the point at which the object balances when put on a pillar or pivot. When the stick rotates in the air, the complete motion of the stick is what? Translation and rotation. Its center of mass has translation, but its end has rotational motion. As the stick or hammer rotates in the air around its center of mass, all points, including its ends, moving in a rotational motion. But its center of mass moves in what? Translational motion. As you can see in this figure, this is hammer. Where is the center of mass of the hammer? Assume that this is hammer, okay? What is this? This is hammer. Where is the balancing point of the hammer? It is too easy to finding the balancing point logically. Logically, the balancing point of the hammer is located near, slightly to the heavier side. Which side is the heavier side? We know that this side is the heavier side. So the center of mass is located here, okay? So the object is rotating around the center of mass. Where is the axis of rotation? If you throw this hammer into the air, the center of mass becomes the axis of rotation of the object. So this is irregular shape. For the irregular shape, how can we determine the center of mass for irregular shape? We studied about the regular shape, as I mentioned before. For the regular shape, center of mass located at the middle of the center, at the middle of the object, such as a meter stick. The meter stick, its balancing point is located at 50 centimeters. Okay, for any other regular shapes such as ice cube, its center of mass is located at the middle, exactly at the middle. Okay, but what about for irregular shape? Irregular shapes such as a hammer, bat. Okay, In that case, where does the center of mass of this object located? In that case, for the irregular shape such as hammer, the center of mass is located near or close or slide to what? To the heavier side. Okay? Where is the axis of rotation? This is balancing point, center of mass, and also center of the gravity. At this point, the object becomes balancing. In the case when you throw the hammer into the air, this is center of mass. Moving in a translational motion, in a parabolic shape, tracing parabolic in the case of the absence air resistance. Okay? So the point around which is the hammer rotated is the hammer center of mass. The center of mass traces out parabola. That is characteristic of the projectile motion. Okay? All points, including it is and moves in rotational motion. When you throw a stick or hammer into the air, it is center of mass moves in what? Translational motion only. Trace out parabolic. For regular shape, center of mass located at the center, exactly at the center. But for irregular shape, such as bat or hammer, it is center of mass is what? Close to the heavy side, yes. Can you say far to the lighter side? Yes, of course, both are correct. As you can see, this bat, where is the axis? Where is the center of mass of this bat? A, B, C, D. Which point has center of mass, or which point is the center of mass for this bat? Point C. Why? Because point C is close to the heavier side. Which one has heavier side, heavier mass, more mass? This end has more mass, so that is why this point becomes what? The center of mass or center of the gravity. Okay? For most situations, the center of mass and the center of the gravity are equivalent or is the same. For more complicated objects, calculating the location of the center of mass is more difficult and is beyond the scope of this book. We will not study and we will not give you in detail for the irregular shape. Okay? So we focus only on the regular shape. A center of the gravity, its definition is the position at which the gravitational force acts on the extended object as if it were a point mass. We have some questions related with the point mass and rotational motion when we throw a stick or an object into the air. A twirler throws a baton in the air, such as throwing this pen. Okay, a twirler throws what? A baton in the air. Describe the motion of end. Of what? End. As you know, the end's motion is what? Rotate or spin. The end, they spin or rotate about the baton center of mass. B, branch B. Describe the motion of what? Center of mass. As I told you, in the absence of the air resistance, the center of mass of all objects, they are moving parabolic. In parabolic motion. In what? Parabolic motion. It's very important. Be careful, please. This is the same question. This is question 14 in chapter review. Okay, but this is my question for you. If a stick is thrown into the air, what is the type of the movement of end? End always rotating around a center of mass. Rotational motion. What is the type of movement of the center? Translational motion. Okay? Question 15. A projectile is fired into the air and suddenly explodes into several fragments. As you can see in the fireworks, in the New Year or in any occasion, for example, when you see the fireworks, when it explodes, when it's fired into the air, explodes into what? Several fragments. What can be said about the motion? Motion of what? End or center? Center of mass. What is the motion of the center of mass? In the absence of air resistance, as I told you, the center of mass of all object is what? Moves along parabolic motion. Parabolic motion is translation or rotation? Translational motion. Change position. Okay? The center of mass is always a point of the axis of rotation. Okay, so that's all for today. Inshallah, in the next lesson, we will continue explaining section 2 in chapter 2, rotational dynamics and rotational equilibrium. Okay, thank you for listening. Hope you get it.